Welcome to our next episode in our flow series, and today we want to have a look how we can combine our flow with an external or third-party systems like you would normally have in industrial applications. It could be Modbus, OPC UA, or maybe HTTP. We won't cover OPC UA in this video, and we want to use our spot color detector to play red and green light detection. And for that I have here some triggers already set up, and basically we want send the red lamp state if it's on or off to an OPC UA server. And I will save this, go to our flow, and I've already created here something. It was for testing, but we start from fresh. The first step would be we subscribe to this event, science the spot color detector create metadata events, and we get from there the info, is it on or off. We test it and see, okay, it's on or off, and it switch from one to other state. I will now adding the WebRTC stream because it has a better latency, so that we see what's going on. Let us test this once, and we will see here our red lamp is now on and it goes off. And now we want to transmit this to our OPC server, and the OPC server just want true or false from us. So we need to compare the string on or off. So we need a compare node and a string input node. So we compare the color name. I name the colors just on and off, so it's easier for us. And I will compare this one. And you see, only when this is on, we got a true signal, and when it's off, we have here this false value. So we are now already have a pole value that we can transmit to our OPC server, and we would need here now an OPC UA client node, and in my case this is OPC TCP. And I have this port. We want that this is always connecting, connected. And we want to do a write operation, and for that we need the connection key from the connection. And what we are writing a Boolean value. We don't want to have, or the default value would just be no. And let me look what we have for the variable name. Should be this one. And basically we are now need to wire up, because this is the value, and then we need to have a signal when we do the write operation, and we want to do this on each change, but after we do the comparison, so we need to trigger this on the next cycle, and for this we use our next cycle parse. And like that. A little bit of clean up here. Because if we don't would use the next cycle pulse and we trigger it directly from the new event, this trigger would reach the right node before we have done the comparison, because it has an execution order, and that's why we need this next cyclic pulse. Basically, we are now, each time when we got this trigger, we sent the correct data out to the OPC server. And of course, we are not limited to our OPC UA. We can also send this via Modbus, so you can write a coil, which basically would mean it's you write an Boolean value, so 0 or 1. You can of course also send this via HTTP out to a third-party system, and you see it's very easy to come from an Axis event. This could be any ACAP or object analytics. We are not limited to the events. We just need to be available through an ACAP, through Axis or third-party ones. And thank you for watching. See you next time. Bye.